Okay, guys, so we're going to talk about domain and range, and I want to share with you those problems from Delta Math. So one from each section of the Delta Math. So we will do that right now. So here we have a problem, and we're going to find the domain and range. And so first of all, we want to remember that domain is our x values, and the range is our y values. So first of all, we're going to look at domain. All right, so I'm going to so I want to look at here's where the x starts and here's where it ends. So on the x-axis, I want to look at this beginning and the end. So for domain, we're looking at x's. So we're talking about x, so I'm going to put x in the middle, and then I'm going to put the lowest number over on the left-hand side and the highest number on the right-hand side. So -2 to 9. So x, all the possible x values are between those numbers. So I need to represent them using either less than or equal to in both parts. So we have to figure out which one it is. And that all depends on whether we have an open dot or a closed dot. So since there is a closed dot here, that means it includes it. So x is greater than or equal to -2. It includes -2. But since this is an open dot here, that means it's just going to be less than 9 because it does not include 9. Now, if you're looking at the Delta Math, then they would have put it this way, bracket -2 comma 9. The bracket means it includes a number, parenthesis means it does not. Okay, and this is called interval notation. Interval notation. Okay, so let's look at range then. So we'll get rid of these and change our color. So let's go to red. All right, so range, we're looking at the lowest value. How low does the graph go on the y-axis to how high does it go on the y-axis? All right, so for range, we're using y. So it goes to the lowest spot is -3, so we'll put -3 on the left. And the highest point is 5, so I'm going to put 5 on the right. And now we're still using these same notations of greater than and less than. So we're still using this. All right, so since it does not include at -3, that's going to be the less than symbol here, but it does include here, so that's less than or equal to. And if we're using interval notation like on Delta Math, that would be a parenthesis because it does not include it, the -3, and a bracket because it does include it on +5. All right, so there's one where we have defined endpoints for both the domain and the range. All right, so let's look at the actual function. So here's one that says find the range, and we're actually going to talk about domain and range here also. Find the range for the function x minus 2 quantity squared minus 8. So here's the function. I already graphed it on Delta Math or on Desmos. All right, and so let's talk about domain first of all. All right, so go back to our green. All right, so domain. In this case, whenever it's a function that is a quadratic, a parabola, this is a parabola, or absolute value, or exponential, the domain is always going to be all real numbers. And that's because the graph never stops moving from left to right. As I go from here, it's going to keep going to, so on the x-axis, it's going to keep going to -infinity. And on the x-axis this way, it's going to keep going to +infinity. And the graph's never going to stop moving. So that means it's all real numbers. All right, so let's look at range then. All right, for range. All right, once again, we want to look at, that's y. And we want to see, okay, what's the lowest value it goes to? So on y, the lowest is down here at -8. And here we can see that the graph, these actually are arrows here, the graph goes on forever. So that means that all I have is a lowest value. And since it does include it, So we would say y is greater than or equal to -8, and it's less than, you could say, positive infinity, because it goes on forever. But we don't put that down. We're just going to say that y is greater than or equal to -8. Now on delta math, then, if you did that though, we would put a bracket. If you wanted to do interval notation, be a bracket because it includes -8. Then it goes on forever. So then we would say goes on to positive infinity. And since positive infinity is not an exact value, we put a parenthesis there. And the same for the domain. You could have done that using interval notation. It starts at -infinity, and then it goes all the way to positive infinity. And whenever we use -infinity and positive infinity, we always use parentheses because those are not exact values. All right, now I want to look at one more problem, the other type we did. And so I actually have it up here on Delta Math, so I want to do it from there. All right, so here college has a financial aid formula that applies to applicants whose family's income is below a certain threshold. The financial aid can be determined by the function f of x equals 15,000 plus 1,000x, where x is the number of siblings, including half siblings and step siblings, that the applicant has living in their household. Find and interpret the given function values and determine an appropriate domain for the function. Now, in this problem, we're talking about people, and people have to be whole numbers. Okay, so they could be 0, could be 1, could be 2, but they can't be negative, and you can't have partial people. So you're limited to whole numbers here. So the whole numbers are 0, 1, 2, 3, 4, 5, and so on. All right, where other situations you could have fractions. Okay, we could have partial time. But a lot of the things you have to pay attention. Could I have a partial one of those things, or do I have to have a whole one? All right, so now the nice thing on Delta Math here is I actually clicked on this part right here, and here it gives me an actual calculator I can use. And so let me move my picture out of the way. So this says find f of -3. So I can actually do that right here on Delta Math. So 15,000, type it right in here, plus 1,000 times -3. And my answer is 12,000. So I'll put 12,000 in here. Meaning a qualified applicant with -3 siblings in their household will get $12,000 in financial aid. This interpretation does not make sense because you can't have negative siblings. All right. F of 3. Oh, this is nice because all I got to do now is just change this, get rid of that negative. And now we've got 18,000 for 3 siblings. We get $18,000 in financial aid. And this does make sense because we're talking about a whole number. Okay, 3 is a whole number. All right, then 3.5. All right, they're helping us out again here. All I got to do is put the 0.5 in here. All right, and that gives us, we can see the answer over here, 18,500. And for 3.5 siblings, and 18,500. And oops, 1, 2 zeros. And this does not make sense because you can't have half of a sibling. Okay, so based on the observations, it is clear that an appropriate domain for the function is. And so all real numbers, no, because you can't have a partial person. Non-negative real numbers, that just means all of the starting at 0, so 0, and then I could have 0.5, 0.7, no, that doesn't work. Real numbers in A to B, that's not true either. Okay, that would be a starting and ending point. Integers, can't have like -3 is an integer, but you can't have negative. So this would be the whole numbers then, because you could have 0. Okay? So select that, submit our answer. This, say yes, and there we go, we got it right. All right, so that's how you do those problems for a domain and range. Hope that helps you guys.